Now, today I'm going to take I'm going to say the first hour. I'm not sure whether I'm going to need an hour or not, or more or not. And Frank is going to join us for the second half of the lecture. And he's going to start looking at the front end part of this module. So, we're still here. And really what I want to do with you before I sign off is to just finish up the Cognito stuff that I was talking about the last day. And having done that, you can then work your way through this lab here, if you haven't done so already. And as I did mention to you last week, you can reuse any amount of the code in the Cognito lab for your assignment. Right, so let's pick up the Cognito stuff. So we know Cognito is the service that looks after essentially kind of user accounts for you. Where at the start of these slides. And with Cognito, we create the main resource is this idea of a Cognito user pool, which is a bit like a database of your user accounts. And Cognito provides the standard kind of authentication and authorization functionality is kind of built into it. You have to do a little bit of lifting, okay, but it does some of the work for you, and it generates JWT tokens and all that kind of good stuff. So the last day then I said that this is the typical, you don't have to follow this architecture, but it's the kind of typical architecture that we use when, sorry, no, that we used when we're using Cognito in conjunction with a web API based application. You can use Cognito for non-web API based applications as well, but given the title of this module, that's the nature of the application that we are interested in. And what I was saying was that what you tend to do from an architecture point of view is you have one part of your application that's responsible for dealing with all authentication stroke authorization type requests, and another part of the application that deals with the core functionality of the particular problem domain that the application is targeting. And when it comes to a web application, that means that we tend to have two web APIs. You could have more, actually. You might actually break the core functionality, the domain functionality, up into multiple web APIs. But as a minimum, you might have two web APIs. The top one in this diagram is responsible for dealing with all authentication-based requests, and the bottom one is responsible for handling requests targeting your domain functionality. And you can imagine that there are a number of lambdas here in this part, and each lambda is responsible for dealing with one particular aspect of authentication stroke authorization, like sign up, sign in, sign out, sign up confirmation, that kind of stuff. And I talked about the flow of control to the last day, and I also demonstrated using this web API. And ultimately, when a user has registered, confirmed their registration, and logged in, then what Cognito does is it will generate dynamically a JWT token, and that token is then sent back to the client. Client doesn't have to be a web client. It could be a native mobile client, sorry, or it could be a desktop client or anything of that nature. And that client then uses that JWT token whenever it is communicating with the domain functionality, and in particular when it's trying to access a part of the domain functionality that is protected or private, i.e. it needs to be, the user needs to be authenticated. And the token is sent with the request over HTTP. This web API then uses a local Lambda function, this one here, which we call the authorizer. And the purpose of the authorizer is to validate the JWT token, and it does that by communicating with the Cognito service. Why is that popping up in front of me? Can I just check that people can hear me?
Yep. Yeah.
Okay.
Yeah.
Something has popped up on my screen. Just give me a sec.
Might be something to do with me, Dermot. I just jumped.
There's always a culprit. No, what has actually popped up, Frank, is just the participants on the right. Just give me a sec. I'll see if I I've shut off my camera. When I shut off my camera, okay, maybe that'll do it. Yeah, okay. I'm still sharing my screen, aren't I?
Yeah.
Yep.
Yeah, okay. Right. Yeah, this Lambda here, it's going to be communicating directly with Cognito for the purpose of validating the JWT token. And the way it actually works is if the token is okay, then what it does is it will dynamically generate an IAM policy. And the purpose of the policy is essentially to allow the request that originated here to go right through to the back end. I'll leave it like that for now. We'll see a little bit more detail of that in a second. I just want to step through, not in any great detail, these lambdas here. Before I do that, and we saw this the last day, this is the CDK code to create the user pool. Whenever you create a user pool, you have to create a client for that user pool, and the client is what a Lambda will use in order to communicate with Cognito about that particular pool. Okay, so that's what the purpose of this guy is. And so I demoed the there's two APIs, as we know. The one on the left is dealing with authentication. The one on the right is dealing with your domain functionality. And I'm showing you down here on the bottom right the fact that there are a number of lambdas that are just solely concerned with handling authentication stroke authorization requests. And we can tell what each of these lambdas does roughly based on the name of the lambdas. These two lambdas down here represent my domain functionality Maria, even though they don't really actually do anything. They just send back a response. So I demonstrated this the last day. This is a screenshot from Postman where I'm trying to do a sign up or a registration, and this is the body of my request. Now, when I click send on this request, this is the Lambda that ultimately gets executed. I know I'm going to jump around a bit, but so we're talking about one of the Lambdas here. Okay. This Lambda, and this Lambda is going to be communicating with Cognito. Now, not by accident, the way we communicate with the Cognito service is similar in style to the way we communicate with the DynamoDB service. Okay, in other words, the SDK, the DynamoDB SDK, is designed along the similar lines to the Cognito SDK. What I mean by that is it's all based on these command objects. If you remember when we were trying to get a Lambda to communicate with DynamoDB, we were creating a scan command object or a query command object. And it's that kind of command object pattern that's used here as well. So anyway, the Lambda, first of all, we have to create an instance of the Cognito SDK client. That's what we're doing here, just as we created an instance of the DynamoDB SDK client when we were trying to talk to DynamoDB. This is the Cognito SDK client. Here we're just extracting the data from the body of the request. This is a sign-up request, and so the body contains the username, the user's chosen password, and the email that they want to use associated with this account. Here we are creating, in this case, we're creating a sign-up command object properties. The first property is a reference to the Cognito user pool client. This here is a reference to this guy here. And the other parts then are just the body of the request. Here we're creating an instance of our sign up command object itself, and we're sending that command object to my Cognito client. And hopefully Cognito comes back with a success response, and I'm just sending back a response back to the client, to the, let's say, our React client. So that's pretty straightforward, I think. We know that the way the authentication flow that happens is sorry, no. I go backwards or forwards? Sorry. Oh yeah. The registration or sign up, as we know, is a kind of two-step process. The second step is confirming your registration, if you like. And the way what Cognito does is it sends us back via the web API, it sends us back a code, and we need to send that code to Cognito. So this is a screenshot from Postman where we're issuing a sign up confirmation request. Yeah. And so the Lambda, eventually, when I send this request, another Lambda is going to be triggered, and this is what the Lambda looks like in this case, and it has the exact same flow of control as the sign-up Lambda. Yeah, and the only difference is, in this case, we're creating an instance of what Cognito SDK calls a confirm sign-up command object. Properties, again, a reference to the user pool client and the actual data. In this case, the code and the code that Cognito sent us and the user's username. We send that ultimately to the Cognito service via our SDK client, and hopefully it comes back with a successful response, and we send a successful response back to our React client or whatever client we're happen to be using. I think that all of that is fairly straightforward. The next step typically is you want to do a sign in or log in, and jumping straight to the Lambda that's going to handle that. Similar kind of flow-ish, right? Okay, we have our SDK, Cognito SDK client again. We're extracting the user's username and password from the body of the request. Now, there isn't a sign up command object. There's instead, it calls it an initiate auth command object, but that to all intents and purposes, that's a login command object. Properties are predictable enough. All this one is saying is, this is kind of hard coding, really. Sorry, not hard coding, but it's boilerplate. We have to specify the authentication flow. There are different authentication flows that you may want to associate with your authentication process. We're using the standard one, username, password. If I do get to talk to you again at the latter end of this module, I'll show you another one, which is referred to as a passwordless authentication flow, but that's for another day. So anyway, we create essentially our sign-in command object properties, and we send that to the Cognito service, as we're doing here. Now, the response that we get back from Cognito, in this case, it will be an object structure, but within that object structure will be the JWT token that we ultimately want to send to the front end client or React client, let's say. And that's all I'm doing here. So there's a particular property within the object that's returned called the authentication result. Yeah. And that's also an object. And within that object, there is a key called the is token key. And that key will have a value associated with, and the value will be the actual JWT token itself. That big long string that we saw the last day. And now I'm returning, so this variable here, token, is going to be a reference to the JWT token string. Now I'm returning that in the body of the response down here. Probably not a great idea to do that. So it could potentially be hacked, but I'm just doing it for our purposes. What's better though is to send the token as a HTTP response cookie, which is what I'm doing here. This is how you include the JWT token as a response cookie in the HTTP cookie response header, which is a mouthful. Okay, so that's what's going on here. And so when I demoed this the last day, the screenshot again is from Postman, and it's showing me down here. Look, it's showing me, look, this is the token that was included in the response. So I've already pressed the send on this request, and here's the JWT token. But I said, if you want to get the token that's included with the response cookie, then you go into click on this here, and this is what Postman shows you. So here we're looking at the in general, there could be a number of cookies in the cookie response header. In our case, there is only one, but there could be many. And so this is just showing me, look, there is a cookie. The key associated with the cookie is called token, and the value is this thing here, which is my JWT token. All I'm showing you in this screenshot, I don't know how familiar you are with JWT tokens or not, but you can actually, this is a simple little website, jwt.io, and where it's useful is when I pasted in the cookie, then this page will decode the cookie, and you can see on the right hand side that when I look inside the decoded data, it actually includes the user's username, and that's really what Cognito does. When you give it a JWT token, it needs to validate a token. It essentially decodes it, looks inside the token for the username of this user, and then checks in the user pool. Does that user exist in the user pool? And if they do, then it's a valid token. So that's the only purpose of this screenshot, just to show you what a decoded JWT token looks like. You can see it on the right. So at this stage now, I've admittedly very quickly gone over the main lambdas that are here and how we code them. And I give you this code in this week's lab anyway. So at this stage now, we have our client here has a JWT token. And for any part of the domain functionality that it wants to access, in our case, they're implemented in lambdas, but they don't have to be, then it needs to include that token in the request. And again, I'm including the token in a HTTP request cookie. That's arbitrarily, that's how I've decided to include the token in a request. When that token arrives here, this lambda needs to be consulted, and it will verify the token by talking to the Cognito service. So we need to look at how do we configure this particular web API so that it gets to use this lambda. So there's the CDK code for that bottom web API. So we're creating an empty web API, if you like, here. I'm adding 2 endpoints. So this is my kind of what I'm calling my domain functionality. So I've got a protected endpoint, or an endpoint with the path protected, another endpoint with the path public. And the names are chosen for a reason. I obviously have a lambda for each of my 2 domain endpoints. We're not interested in the lambdas though, but that's what's going on here. This lambda is the lambda that's going to play the role of my authorizer, but it's just an ordinary lambda when we created it initially. It's this code here that makes this lambda actually play the role of the authorizer. So we need to create, in the CDK terms, we need to create an instance of this request authorizer. So this is another example of an L2 construct in CDK. In terms of configuring this guy, the purpose of this setting here is to tell the authorizer that the token is going to be included as a cookie, because there are different ways. I jump back to here. There are different ways that you could include the token, the JWT token, in a request. One way is just including it as a cookie, a request cookie. And so that's what this setting is essentially doing. It's telling, it's kind of telling this guy here really that that's where you'll find the JWT token inside the cookies. The rest is, this is just a reference to the implementation of the authorizer. And okay, I'm deciding that I don't want my lambda to cache any tokens. Caching would obviously mean that it would, subsequent receipts of that cookie would be verified much quicker than having to actually talk to Cognito. But I've decided I don't want to cache them at all. So let's lift it as duration 0. These then down here then is where I'm kind of fleshing out these two endpoints, because at the moment these two endpoints, my domain functionality endpoints, don't have any backends associated with them. Here I'm fleshing them out, and we've seen this kind of code last week. But what's different about if we take this endpoint, the protected endpoint, we are saying that we are associating an authorizer with the endpoint, if you like. This here is just referring to this up here. And okay, I'm also indicating the type of authorization. That again is kind of boilerplate. So the effect of this bit here now is to relate this lambda with one particular endpoint here, if you like. Here's the fleshing out of the second endpoint, and in this case, I'm not specifying any authorizer, okay, which means that this endpoint is publicly accessible. So even if I include a token with a GET request to this endpoint, then the authorizer won't be consulted at all because I haven't configured it like this. This is only a screenshot showing you how to set up the cookie as a HTTP request cookie, but I demonstrated that the last day, so you can look at last week's lab to remind you how to do that. And you will be doing all of this in this week's lab anyway. Now, if I go back to here, rather than stepping through the code for this, because in the lab I give you the code for it, and obviously it's a good idea maybe just to scan over the code to have an understanding of it, but you won't need to go near the code to do any editing of it. And so rather than talking my way through the code kind of bit by bit, all I'm doing here is just giving you an outline as to what the authorizer does, right? The first thing it has to do is it has to look at the HTTP request cookies header. In general, the HTTP request cookies header is a big long string, but it's made up of key value pairs. There could be more than one cookie in general. There could be more than one cookie in the request cookie header. So in the code, what I'm doing is I'm taking the cookie header string and I'm parsing it and putting the results into a standard map data structure. And so each key in the map data structure represents one cookie key, and the value represents the cookie value. in this map, I then go looking for the cookie whose key is token, because that's the name I decided to give the JWT cookie. So obviously, if it doesn't find the if it doesn't find the token cookie, then that must mean that the request doesn't have a cookie at all, right? And so the request should be prevented from accessing my domain functionality. Now, the way you need to do it is you need to dynamically create an IAM policy that expresses the fact that this particular request should not be allowed essentially to execute the web API. This is kind of how I explain it, right? If you think of a request coming in, there's kind of two parts to the web API dealing with the request. The first part is where it consults with this guy up here. And if that finds that there is a token in there and it's a valid token, then it needs to somehow tell the web API, you can now continue on executing the rest of your task and pass it on to the backend. Okay, so there's kind of two parts to the actions carried out by the web API, and the way my authorizer tells the web API whether it should continue on processing this request or not is via an IAM policy. Just like everything in AWS is via, everything related to security is related to IAM, then that's how we do it here as well. It's not kind of returning a true or a false or a Boolean true or false. It's using IAM. So if it doesn't find, if there is no actual JWT token in the request, then I'm saying here to return an IAM policy denying access to, the second part of the web API's functionality. This is the only part that I might look at in the code. So this is the lab now that you will walk through this week, and here's my various lambdas. Here's my authorizer, and my authorizer is, let's see, where is it? It's using this local utility function called create policy. And just look at the second argument. Okay, the second argument is a string, and it's in this case it's the deny string I'm sending, whereas somewhere else I think I'm invoking it, and I'm sending the string allow here. Okay, if we look at this function, again, it's a local utility function. And all it does is it returns this thing. Now, this should look familiar to you from those of you that did the cloud architecture module last semester. It's a bare bones, admittedly, but it has the structure of an IAM policy. And depending on what the second string that's passed into this little utility function, and we saw there that one invocation sent the deny string, which is IAM's way of saying don't allow a particular thing to execute or not, and another one was the the allow string. So, and that string is being used here. That's what I call it. And so in terms of the action that this IAM policy relates to is this action here, which is essentially saying to the ability to invoke the API gateway. Okay, so we're either allowing or denying the ability to execute the IAM gateway here, which is, in other words, execute the web API that we've defined. And the resource, I wouldn't worry about it, but I'm referring to the particular web API that is controlling all of this and getting the web API's ARN. Yeah. You don't need to go near any of this code, but I am just explaining, if you could call it an explanation as to roughly how the authorizer indicates that the token was good or bad. You can come back to me with questions if you want a more detailed explanation, but so certainly it will return an IAM policy that denies access if there is no token. If there is a token, it then goes along and tries to verify the token. Now it gets the Cognito service to verify the token, obviously. And as I kind of indicated earlier on, the way Cognito service does that is it decodes the token and then it goes looking up the user pool to see the user in there. And if the Cognito service returns a successful verification of the token, then again, my authorizer either generates an allow or a deny IAM policy to control whether the client request should be forwarded on to the domain functionality or not. I'll pause for questions, although it's probably hard to formulate a question based on the way I described that there, but I'll pause anyway for a second in case there are any questions. No. Okay. Now, there's one other thing that I want to look at. So that's Cognito. There's a lot more to it, but that's as far as we'll look at for now. If I do get to come back to you again, then I'll look a little bit further at it, at the internal kind of workings of it. But you've got enough to be able to use Cognito, hopefully, in the assignment at this stage. I want to talk about something else before I wrap up, and I'm going to talk about it in the context of the lab that she completed last week. So this is what we're looking at right now, and so I'm looking at the CDK stack file here, and we know what this code is all about. Okay, this is about controlling what my lambdas what services my lambdas can interact with. And in particular, it's controlling what DynamoDB privileges my lambdas have. And so if we take this one in particular, so this is the, let's see, we're looking at the movies table, and we're granting this lambda, which is the lambda that tries to read all of the movies from the movies table. We're granting that lambda read access to my movies table. Now, that line of code, what does the CDK generate up on the cloud for that line of code? So if we look at I've deployed this earlier on now, and if we look at the lambda itself, which is this one, I think. Yeah. And in particular, if we look at the configuration of the lambda and the permissions associated with the lambda, and I told you, and you probably knew that from the previous semester anyway, that each lambda has what's called an execution role associated with it. The execution role controls what other services the lambda can talk to. And that is expressed in terms of policies, IAM policies, something we were talking about there a while ago. Now, best practices, as we know as well, that each lambda gets its own IAM role. And here's a reference to the IAM role that my CDK framework has generated for this lambda. If I click through to that, so this is the details of the execution role for this particular lambda. And we can see that there are two policies, IAM policies. associated with the role. This is the one that I'm particularly interested in. This IAM policy was generated on the fly by the CDK for this particular Lambda based on the CDK code. And so if I click through to that, here's the IAM policy. And surprise, surprise, the policy is all about DynamoDB actions. And if you scan over the actions, you can see they all relate to kind of read-related actions for DynamoDB. So each of these lines, again, for those of you that haven't seen this stuff before, although I won't claim now to give you a full understanding of IAM, unfortunately, but each of these lines refers to a service, the DynamoDB service, and an action. The action is a bit like one of the API endpoints for that service, but they're all read actions. So this policy with this particular set of actions, that was all generated dynamically by the CDK for me. So the question is, well, what if we, and that was all as a result of this little convenience function. But what if that was not available? What if this convenient function was not available to us? How would we get the same end result? In other words, if I comment that out, but I still want the same kind of permissions to be associated with my get all movies, can I do it in CDK world? And the answer is yes. You can write your own IAM policies in TypeScript using the CDK framework and attach that policy to a role and associate that role with whatever. In our case, we're associating it with a Lambda. And so this is the equivalent. So I've disabled this line here, but I've written this code so that my get all movies will still work. Now, when I looked at the kind of reversed engineered, to be honest with you now, right? But when I looked at all of these actions here, I know that in fact, some of these actions aren't being used by my get all movies Lambda at all. In fact, if I spend a little bit more time investigating it, I'd say it's probably only this action is the one that's used by my get all movies Lambda. But what I essentially did was I just copied this, grabbed all of this, copied it, and pasted it in here. And I kind of took out the ones that I definitely knew my Lambda didn't need. And I left it to a few that it potentially needs. Although, as I said, it's probably only this one. So, so the policy says to allow these actions, and I'm allowing the actions on this particular resource. The resource in this case is my movies table, but you have to specify the ARN of the resource, the Amazon resource number, which is kind of a unique identifier for that resource within the Amazon cloud. So that's all I'm doing there. You could be lazy. I could be lazy and just put in, this is a string. I'm using string templating here, but I could be lazy and just put in the string star, that would be fine. We would be a little bit over privileged, but anyway. So if I now having made those changes, if I now do CDK deploy, and then we look at the IAM policy that has generated by my my kind of raw, if you like, IAM code here, and then see, well, does my Lambda still work? And hopefully we'll find that it does. So the reason I'm doing this at all with G is because he may, quote unquote, need to generate an IAM policy for a Lambda in the assignment. Okay, there may not be a convenient method like these guys that will do that work for you. Like these methods here are obviously related to the DynamoDB service because it's just a commonly used service by Lambdas. But other services that may not be that commonly used, or else, the CDK development team haven't actually created these kind of convenient functions for us, then that's when we have to resort to writing our own IAM policies. So that's why I'm showing you the actual syntax for doing that. Okay. I'm running up close to my time. Are you still there, Frank? No.
I am there, yeah.
Are you? Okay, I'm nearly finished.
No, take your time, it's all right. This would take your time.
So just while we're waiting, we go back to okay, so it has deployed. And if we go back to our Lambda, do some refreshing, although it's the same role really, it hasn't changed the role, let's say. So yeah, so that's my Lambda. And if I look at the drill down into the execution role, and here's the IAM policy. I'm just going to refresh this because it probably needs to create a new one. So it has a slightly different name. So you can see now that the policy matches my IAM or my CDK code. And hopefully this doesn't blow up in my face now if we just try and actually run the Lambda or trigger the Lambda. So this is the web API's URL. And if we add on /movies, okay, so we're getting the movies. So it looks like it's working okay. Right. So that's that. As I said, you may and definitely will need to do something like that in the assignment at some stage, possibly depending on how far you want to go on the assignment. Just on the assignment, is there anything that you want to ask me about it at this stage? No? Okay, that's fine. That's me done, I think. So I'll hand over to you, Frank.